Welcome to Link G4x Training Part 37. In this video, we're going to be taking a look at working with our VTEC functionality and programming in our G4x systems. So if we have a Honda engine that's a B series, D series, K series, H series, F series, there's going to be a tremendous amount of engines that run our VTEC functionality. VTEC is going to be when we have two cam profiles that's going to be actuated and turned on based on a commanded output to our VTEC solenoid. When that solenoid turns on, it's going to be allowing oil pressure to go in and lock the rocker arm assembly in a cylinder head. It's going to be switching our cam profile. What we're going to find is that we have the ability to program when we have the VTEC engagement point, so we can switch between low and high cam, and there's going to be an ideal point for every engine configuration you're going to be working with. So we'll learn how to program our VTEC output based on conditions that we program. We're also going to be taking a look at how to properly integrate the fuel and spark timing calculations so that we have a fuel table and then a spark timing table associated with our low cam of operation and a fuel and spark timing associated with our high cam operation. We'll find this is exactly what Honda's done in the programming in the factory ECUs. We're going to be mimicking that and learning how to integrate that into our calibration process. Without further wait, let's jump into our video so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our VTEC functionality and programming within our PC Link software. If we're trying to control a VTEC equipped engine, so a Honda engine that has the VTEC functionality, we need to be able to switch over from our low and high cam profile, command it from our Link software here. We're going to be turning on our VTEC solenoid when we like. Usually it's based on engine RPM at the very minimum. And when we switch over from our low to high cam operation, we need to properly characterize the additional fuel and spark timing delivery based on that high cam operation. On the high cam, we're going to have higher lift and more duration. As a result, we're going to be moving more air into the engine, so we're going to need more fuel, and we need to go and have a separate table to be able to add additional fuel in. Same is going to go for our spark timing. When we switch over to our high cam, we're going to find that because it has higher lift and duration, our cylinder pressure is going to change a bit. Our dynamic compression or the working compression is going to be changing. We're going to be dropping a little bit of cylinder pressure. To gain back that lost cylinder pressure, we can advance our spark timing a bit more when we're in our VTEC operation. So we're going to have a two-part effect. One, we need to make sure we program our output so it turns on the cam switch at the proper time. And then two, making sure we have our fuel and spark timing accounted for so the engine's going to run properly and it's going to produce power when we're in our high cam operation. So what we're going to do here is actually jump in from our layout all the way towards the last two pages here. I have two pages dedicated for doing VTEC fuel tuning and VTEC spark tuning. It's actually quite simple to set all this up. Let's jump into our VTEC fuel and take a look. Now within our window here, we're going to have our table 1 and our table 2. Table 1 is going to be associated with our low cam operation, so we can just designate one fuel table for low cam. Then we're going to be virtually pairing our table 2's activation, so we can see it's showing on fuel table 1, fuel table 2 is inactive. Fuel table 2 will go active when we switch over to the high cam. We need to pair things virtually as we're doing our programming in our general purpose output, as we're going to be talking about here in just a minute. And we're going to find the same is going to go for our VTEC Spark, so we're going to have another window over here we'll look at in just a little bit within the training module here. That's going to allow us to have two distinctive spark timing profiles based on the camshaft being in the low cam operation or the high cam operation. So now that we've covered the basic idea of what we're going to be after here, let's go into our GP output. This is going to be our general purpose output. This will allow us to assign an auxiliary output for our VTEC switching function. Right now, I'm just going to go set this to none so we can go through this in a fresh window. So we're going to go into our output here. We're going to be designating and selecting the output that we want to use in order to turn on our VTEC solenoid. Now the VTEC solenoids are going to be activated on a high side output or a 12 volt out. The solenoid itself is going to be bolting to the cylinder head. That's where it grounds to. So we'll find that we need to have on the single wire, it's usually a green with a yellow tracer. That's going to be where we send the 12 volt from our aux output or a high side output to the actual solenoid to activate it. We do not ground it. We need to make sure it's going to be a 12 volt output. We have some options here. We choose aux outputs. We can designate those for low or high side output. We also can repurpose some of our spare coil or injector drivers. Right now I have a coil driver 7 and 8 available. I could use those as well. I'm going to be using an aux output because I have these available. So I'm just going to grab, let's say, aux 6 here. It doesn't really matter which one we use. They're all going to have that same kind of purpose. So let's click OK. Now in this case, we're going to find that we have next our aux 6 test. This is going to allow us to test our output to see if our VTEC solenoid is functioning, see if it's wired right, make sure everything's going to be working proper. If I go here from off to on, that's going to be then turning on the solenoid. We'll hear it click. If we go to on pulse width modulated, that'll be clicking the solenoid in a on-off state. Usually the on PWM is a better option to make sure that the solenoid is going to be functioning. After you've wired everything up, you should hear that solenoid clicking on and on if we're checking this on pulse width modulated style option. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.